Welcome back to my channel. Thank you for watching me in advance. Let's look at the problem where we need to integrate e to the exponent x over 2 times sine x over 3 dx. You realize that this is an N6 problem, and if this problem is asked there, normally it would be for 6 marks, but I know when you go to marking, there's a tendency that they double the marks, so that then gives you 12 marks, so to say. But let's look at the solution thereof. When we look at the problem, you realize that this is a product. Product as it is, it means we need to use integration by parts. You must use integration by parts. This is a technique used for integration, which says that if we are integrating u dv as a product in u times dv, in the same way you will have e to the x over 2 times sine x over 3 dx. Then the integral will be uv minus the integral of v du, which then means that we need to take this, break it down such that we are able to build on this, because when we shall have built all these parts, we will then be able to make a move. But also the other knowledge that we need to have is that of the Liate rule. Now the Liate rule actually guides us when we need to be saying let u equals e to the x over 2 where now if we say let u equals e to the x over 2, then we are saying that the part that is left after saying let this be u, the part that is left is the dv. The dv will then be the sine of x over 3 dx. Now when you look at this, there's two parts there. Remember the technique integration by parts looks at one part as differentiation, the other part as integration. So those two parts are combined together in this technique. So it's a very, very important technique, and at times a very confusing technique. Now to the u part, we're going to du dx, which means we're going to differentiate this part, and the differential here is half e to the x over 2, where now the du will be half e to the x over 2. Now when you check with this part under integration that I've just done, you've got the u and you've got the du. Where do we get the v? We get the v from the dv part. If dv equals that, then v will be the integral of sine x over 3 dx. And now we need to integrate that part. When we integrate sine x over 3 dx, the integral will be the cos of x over 3 all over 1 over 3. And this, when you simplify, it will be 3 the cos of x over 3. You will see this as 1 divided by 1 over 3, which will then give 3. Now this will then be the v part. So now if you look into the u dv equals uv minus the integral of v du, you can see that we have got the u the v and the integral v du. So all these parts are there now. So let's look at this. What is the u? U is e to the x over 2 there. That is the u. What is v? V is 3, the cos of x over 3 minus the integral of v. V is 3, the cos x over 3. What is du? Du is half e to the x over 2 dx. That du is half e to the exponent x over 2 dx. I'm sorry on that. This is more like making the du the subject of that part. So there we are. But now when you look at this, you realize that we can simplify. Okay, now when we look at this, we can simplify this part. Now let's simplify this part. I don't have space, so allow me to take off here. Allow me to take off all this and then have integral e that the sine of x over 3 dx is same as this is e to the x over 2 by the 3, so I can put the 3 there, and then the cos of x over 3 minus, I can take out the 3 over 2, then integral the cos of x over 3 e to the x over 2 dx. Remember, this has been taken out here as a constant. Okay, now I can take this off because we have that part there simplified. Now when you check with this part, you can see that, check with that part, I'm sorry, that part you can see it wants us to do the by parts again. Now when we do the by parts again for this part, we will see u v e to the x over 2, where du dx will be half e to the x over 2, where now du will be half e to the x over 2 dx. That is the du. Now this leaves us to have the dv as the cos of x over 3 dx, where v will be the integral of cos x over 3 dx. Now when you check with the integral here, you realize the integral will be a minus sine x over 3, and if I take care of that, it will be over 1 over 3. But I've explained this part when we were dealing with the first part of the problem, which simplified to a 3. Now your v will be that. Now remember this part here will then be the u dv is uv minus integral v du for that part there. Then if I consider everything now, I will start with the equal. Is 3e to the x over 2, the cos of x over 3 minus 3 over 2. Now in there, I need to throw in the uv minus the vdu part. Now, what is the u? The u is that, u, the v is that. So if you look at the uv, I can safely say is the minus 3 e to the x over 2 sine x over 3, which is minus 3 e to the x over 2 sine x over 3. Now, this is the uv. Now, I need to say minus the integral of v du, because I want to take this off. I want us to look at this part and understand it, even after I shall have taken this off, for us to be able to follow. So I will have minus here, we have minus the integral here. Now in here I will need to throw v du, but what is v? V is that, and du is this one. So I can safely do this. I've got minus the integral of v. What is v? V is minus 3 the sine of x over 3 du. What is du? Du is half e to the x over 2 dx, which is this one here. Now it means I can take off this because of the space. Now when I'm here, I need to quickly go there. I can simplify this way. For those who can't do this at once, this will be minus e to the x over 2, the sine of x over 3. Because I want to simplify within the bracket, this will be a plus. Now because I want to take out 3 and 1 over 2 as constants, and I've simplified there, then it means I have 3 over 2 the integral of, I'm left with sine x over 3 and then the e x over 2 and then the x that dx, which means now that I can say take out, I can multiply out the brackets. Now that then makes me to have 3e to the x over 2 the cos of x over 3. Now I can have a plus, I think we'll all see the plus 9 over 2 here, and then I've got ex over 2 the sine x over 3. I will need to consider this there, then I think you can see minus 9 over 4 the integral of e to the x over 2 the sine of x over 3 dx. It's a very long problem. Now when you check with the last part, this is again a by parts, which means that we need to again apply by parts. But when we apply by parts, which you can realize that the same as what we started with, it might mean that if we simplify this, we are going to move from here and get back there. And when we do this one, we are again coming back here. So it's more like there's no solution in that regard. But that cannot be the case, that we will say there's no solution, because when you look at this part, is same as this part on the left hand side. So we will then use this method where we will say let I equal that part integral e to the x over 2 sine x over 3 dx. Because when we do that, we will realize that this part is the I, which is the I there, which I can take down here. And then here it means this part is also the I, which means that I can take this part off and then replace it by I. Because that is what this statement is saying. So I can then take this off. Now when I have that, then I can transpose this part to this side and have this I plus the 9 over 4I equals E number 3 e to the x over 2, the cos of that plus the 9 over 2 e to the x over 2, the sine that plus the constant. Now when you look at this part, let me quickly simplify. Can I take this off? Let me take this whole thing off so that we can all see that this side, because I'm adding 1i plus 9 over 4i, I can see this as 4 over 4, because 4 over 4 is 1. So I can have 13 over 4i equals 3 e to the x over 2, the cos of that, plus 9 over 2, e that, the sine of that, plus c. But now because I'm looking for one integral of, then it means I can counter that by multiplying by the multiplicative inverse, where I will need to counter the 13 over 4 by multiplying it with 4 over 13, which then applies to everything. Then I can say this can be taken out. Then I have 3e to the x over 2, the cos that, plus 9 over 2 e to the x over 2, the sine of that, plus c. Then I can take this off. Now when you look at this, we can still say this 4 over 13, if you check with what is inside the bracket, you can be able to take a common factor, and a common factor can be 3 e to the x over 2 into the cos of x over 3 plus, because I've taken this out and the 3, then it means I'm going to have 3 over 2 of sine x over 3 plus c when I take out the common factor. Where finally I would say that this will then be 4 by 3 is 12, so I've got 12 over 13 e to the x over 2 open bracket, and in the bracket I've got the cos of x over 3 plus that one I need to take down as is, then I can add the constant. It's a very long problem, and you obviously need the concentration all the way up until the integral, which is basically this. But now if you would feel that having to simplify and take out the common factor is a tall order for you, you can actually wrap it up somewhere here or even there. But this is when you are showing that you understand everything perfectly. and this will then be the integral. Thank you for watching, and please keep on following me on my Facebook page as well as on my YouTube channel for a lot more problems like these ones. Thank you so much. Thank you for watching.